inspect what GHC is doing, I believe.
Okay, thank you very much. My name is Iano Kim, and I'm from the Mercury Technologies. So today I'm talking about the ghc-specter, the new plugin, which is I can call it like a show what you're doing right now, ghc plugin. Okay, so yeah, we Haskellers often, and also including all ghc developers, always confront the unexpected problem in very big, complex Haskell projects. And we always ask questions, and why this type error happened, and what these dynamic link errors, and why these modules are recompiled, and also what is the bottleneck of my project build, how much memory GHC uses. We always have questions like that. And in fact, GHC knows it, right? So often, if you know, if you are GHC, and I know why this type error happens and why this dynamic error happens because the configuration is wrong, or I know this module is bottleneck or something like that. But yeah, so I take one example, actually, a real life example in a few months ago in our project. So we upgraded Nix packages, and then the build of our company's products just got broken, and in the upper dependencies from this PostgreSQL simple. And then the error is just that there's no alternative either string instance. Yeah, it should not happen, right? I mean, it should not. There is no such alternative instance, right? But I know this instance was not there, from a long time ago. But why now it was broken? That was the question. And then in the end, when we look at the core expressions from that particular line, and then of course this alternative, the OR operator has the instance of this either string, and it refers to that core expressions. And if you look at the core expression, then yeah, that is from the transformer library 0.5.6.2. So transformer library has the orphan instance of this the alternative of either string. So that's what happens. So GHC already knows it. If you look at the internal state of the GHC, then we already have the answer. But just it is very obscure for us. So if we have some problem, then we should look into the GHC state. So because it is natural, because the answers to many questions are actually what GHC indeed need to know for the successful compilations. But the problem is that most of those information is ephemeral. It's just temporarily existent. Yeah, certainly we can dump information by GHC dedump or turning on some verbose loads, but that is not good for human health. Yeah, it's basically bad for your eyes. Yeah, it's like a fine needles in the haystacks, and it's built-in features, and that means it's limited and not customizable easily. Of course, we are GHC developers, so we can put some new features there with some flags, but first of all, it has a very slow development cycles for new features, and then also it inflates the number of the flags, so that's not really scalable solution anyway. So how about just a print, debug, print here and there in rebuild GHC? That's definitely not a solution, as you know. Yeah. Needless to say, iteration cycle is very long. For example, in my project, if I just change the GHC code, and then if I just build my project, and then it usually takes 3 hours to just have the dependencies ready. Yeah, and so it's not readily available options with the big project. Even you can have a build script which can support the custom GHC anyway. So, but as we know, the GHC can plug in the code. So GHC has really, really excellent plug-in and hook mechanisms. So GHC is a really unique compiler in a sense. So ghc-specter project is from that idea. So if I can make the GHC plugin that can command GHC to stop at the moment of the interest and ask queries. How about that? So, and then if I can ask that questions as we want, then why not make GHC answer the question in the form we want? So information we often want to have is usually in graphical form, right? So GHC has lots of graph structures, and why not just having that graphical form of the structure? And so that becomes okay. Then this project must be like first it should have some plugin component which can be just plugged into the GHC, but also it should have some kind of presentation layer which can show those results very beautiful form and then useful forms. So the ghc-specter daemon is basically the companion process for user interactions and the visualization. Yeah. Okay. So the enabler for this is basically the driver plugin. So this is I often call it the mother of all plugins. So this is a relatively new plugin. I think it's originally introduced in 9.0 time, I think. And the previously it's called the Dyn flag plugin, and which was pretty limited at the time. But it's renamed to the driver plugin, and then it's actually changing the Haskell HSG environment as you want at the beginning of the ghc initialization. So it can govern the initialization procedure of the ghc, and it can orchestrate all the ghc plugins and hooks. That means basically, even you don't have any, plugin parameters for the others, like the many plugins we talked about today. Just you can actually load those things as you want by that driver plugin, in fact. So what ghc plugin, Specter plugin does is basically it establishes a bidirectional socket communications channel to ghc-specter daemon, the presentation layer, and during the ghc initialization, and installs breakpoints in every available plugins and then hook place. So that's the idea. And then also, recently the ghc pipeline code base is very tidied up. So, it's actually the fairly, the amusing experience to use those hooks, especially using the run page hooks. Okay, so in a diagram is like this. So ghc applies on this target project, and then ghc-specter plugin can be installed with that just a simple two command line parameters, just f plugin the ghc-specter, and then plugin package and the package. And then the ghc-specter plugin as a driver plugin, it inserts the breakpoints at parse result, renamed result, splice run action, type check, core to core, everywhere. And then hooks, run phase hook, run meta hook, those things. Okay, and then as I said, it has this socket communication with the ghc-specter daemon. And the daemon is actually organized as a kind of some abstract machine with the ghc, the GUI backend. So abstract coroutine machine, which is organized with the effective system or with the free monad, is actually the backend independent. And then, in fact, the GUI backend can be replaced by any text-based UI or the web-based UI. But currently, the existing backend is right now just a native app GUI. Okay. So then user can interact with this GUI, and then you can just ask queries, or just get by default the ghc-specter plugin also sends some information to this daemon, and then you just get the result. Okay, so I will show the live demo with the actual real project Agda right now. Okay. So here I have some. In this ghc-specter project, we already have the default Nix environment, and then okay, now my Agda setup is just like a so inside the Agda, what I added is just nothing but the.
You need the font size a little bigger.
Yeah. Sorry. Oops. Yeah. Just added these two lines, just plugin ghc-specter and plugin package, and then now I start the ghc-specter. So it just shows the GUI daemon immediately, and then I run cabal build Agda. Okay, it's not showing. So just to save time, I'm just disabling the vanilla library. Okay, then now it shows. Yeah, so all the information from the ghc, and actually, okay. So actually, the basic process ID or this kind of this dynamic flag, and also the RTS information, they are often useful. So I just get it by default. And then also it fetches the graph of the modules. So from the ghc, just the module graph. And I have some, the graph layout library integrated into this. So it just shows the dependencies, and so it's clustered, and then it actually shows the subgraphs and as it compiles, it just shows the the current progress. So, and then of course, without go ahead.
What are the boxes in that part?
They are module. They are module. Yeah.
Repeat the question for that.
What are those boxes? This is a module, but because the Agda has the 429 modules in this case, so actually showing everything is too much. So just it is clustered, and this is basically actually cluster of module, and showing that the most whatever the module which is imported most for and in that cluster. So it's kind of and then by clicking it, I just show the what's inside in that cluster, and then of course without setting anything, you can actually see all the source code because ghc already knows the source code location, and when the compilation is done, I'm sorry, probably I can just when the compilation is done, then yes. Oops. Yeah, so you can see the compilation. I'm sorry, it's a little. Yeah.
I think simplifier ticks, or what are we?
Wait a minute. So sorry. Yeah, I just changed again. So the screen size is too small right now. Yeah, okay. Yeah. So okay, as the
Still small.
yeah, sorry. Yeah, so you can actually show the core graph of the project. So just as it compiles, actually, it knows that the AST of this Haskell file, and then it can actually analyze on live. And also, it shows just a timing of those modules. So actually, it is like this. So one module is really big. Yeah.
Is
so.
that modules or modules and passes on those modules?
Yeah, the modules actually. The modules, just one module. The starting point of each module and then end point of each module for that compilation. And then if I just partition it, then can you see?
Yep.
So you can see that basically the dark blue is just the front end phase of the ghc, and then the light blue is basically after the core, the code generation phase, and the gray is the linking time. So it can show, this is just arbitrarily partitioned it, but you can actually give the more fine-grained partitioning like this. And also, you can also check what is the blocking. Okay, I can freeze. So in this case, this module is blocked by the Agda type checking positivity occurrence, and it blocks these two modules or something like that. So you can obtain who's blocking, who is blocked by this. And then, of course, you can make a graph out of that. So like, this is a whole blocking modules, most blocking modules in this project, something like that. So, and then you can partition it in terms of a number of blocking modules. So this is how it gathers information. But of course, you can also stop the ghc. So now I just pause the ghc, and ghc is really paused here. Yeah, and then it's just pause ghc in this here. So now it is paused and quote core phase. Okay, so then I just do the next. And then it is doing the quote core step after the demand analysis, and then it's doing the quote core after this constructed product result. So you can resume the session arbitrarily and start the session again arbitrarily. So as the breakpoint allows. So then, of course, you want to see what's inside this ghc, and then in this case it's core. So I just want to first of all I can go to the source of this code. Yeah, now it's a code, the Agda type checking on code, and list cores. So it has this model has this cores, and I just just check, I just click arbitrary course and print like this. So, I mean, in this way, you can just inspect what ghc is doing right now, one by one, and then compare each phase, and then how these expressions just change it. Yeah. So, and also another thing it does is basically, this is a GUI program, and this is in a sense just GUI of ghc. So it can do anything. So this plugin allows. So recently, I actually added the support with the ghc debug. So here I'm just running the ghc debug brick. Okay. So now I started the new ghc debug session, and since ghc stopped, I just dump heap. So now ghc is now connected with the ghc debug at this arbitrary position, and I go into and then just pause the RTS right now. Then you can see the internal state of the ghc. Yeah. So this is just a ghc debug brick, and you can see the garbage collection route. From that route, you can just see the actual heap, the snapshot of the heap at the moment. But of course, this can be done better because this ghc debug is designed for the general RTS, but this is for the ghc RTS. So that means right now at this moment, actually I know what's the address of each object. So actually to find a certain object, in fact, you can just use that information from the ghc. Just we can just search it immediately. So right now I didn't implement it yet, but that's very easy to add. Or later on, this brick interface, ghc the debug brick interface can be integrated into this ghc-specter. So this project has lots of different directions to grow. So this is all the live demo I can show. So basically, as I said, this is kind of not the single-purpose project. I really want to make this as a kind of platform for everything that Haskellers wants to inspect inside the ghc. I think this is very good for the ghc developers, but also very good for all the Haskellers. As you know, it is very hard to imagine that the advanced Haskeller does not have interest inside what's going on in the ghc. So just knowing about what ghc does, just by seeing this visual information, it just helps us to be a better programmer, better Haskell programmer. So then we have lots of the interesting directions. So it can be improved in basic UI, of course, and then also here I didn't make many links. I just only show the source code location and source links, showing the source from the start position. But I didn't show one thing. Yeah. So also you can actually make a breakpoint of the compilation. In fact, so that means. Sorry. Yeah. For example. Yeah, so in the source view, I just, for example, I just check this. So I just set the breakpoint, and then even I just resume the sessions, and then when it compiles this Agda utils tuple, it just breaks, and then you just start from examination. So by just a simple UI, the elements, you can have lots of interesting things to do. Yeah. So back to original presentation. Yeah. So I think if I make lots of the linking informations around this this visual information, then we can also have lots of interesting analysis about the ghc. And right now the rather weak point is the backend inspection. This is because basically the ghc doesn't have many plugin points in the backend. So only I use the run phase hook, but that's already the beginning of the backend, the code generation, and the end of the backend code generation. So I cannot see what's inside. So I think I just proposed probably we should have some STG2, like a core plugin, so STG2, STG plugin. Then if it is not used, it should not cost any runtime cost. So then we can use it as a plugin insertion point, and also it can be linked with any linker or the code gen inspection by the external pipeline monitoring if we use LLVM or also the general linkers. And also ghc recently has this kind of multi-process semaphore support. So for this the multi-process ghc Java orchestration, we need to have support for that. And also ghc-i, which is basically long-running stateful ghc compilation, that should be also supported. And also, as you see, the timing graph, if you know how the garbage collection is triggered, or when garbage collection is triggered, or those information, event log integration is also good to be added. Yeah, and actually this is being in progress. So, and then we can also hooks more loggers, and then another very interesting project I can work on this is ghc-i on the ghc itself. So when we stop it, we just invoke the new interactive ghc, run interactive HIW inside the ghc, but with the ghc library is loaded, and then just step inside the ghc with that current status. So that's also very interesting things. And also, as I said, the ghc debug can be also fully integrated with that. Yeah. So this is almost everything I prepared. Yeah. Okay.
Okay, and do we have any questions?
So it seems like there's a lot in here, and a lot of it seems fairly general. Like you focused on monitoring GHC, but it seems like there's kind of a general purpose monitoring story here, trying to come out as well. You have RTS monitoring and the ability to sort of break in the process at various points and report back state and visualize that state. Have you considered how you might take and generalize this to beyond GHC and there's something there?
Yeah, exactly. So I mean, basically I first want to have some really good tool for ghc itself. So, and then as I said, once this is really usable, then it can be used in any Haskell project. So, and then basically librarize those components to the reusable things. It's an easy thing actually. So I first want to have something which is really useful for the ghc is a thing, and then I feel like right now it is a good time for comparing this with the other the available toolings. So for example, HLS and then the ghc debug. This is very complementary in a sense, right? HLS is basically towards the everyday development cycle, and it's basically more focused on the surface layers, like the Haskell language and then type checking. So and iterating as a long-running sessions. But the ghc-specter is more like a very deeply focused on the ghc pipeline itself. And I really want to see all the details of the ghc up to the final code, the binary code. And then ghc debugger shares also some territory, but the ghc debugger is more general RTS tooling. So as I said, for ghc specific RTS can be further developed for the ghc-specter, but the general RTS tooling can be shared, and then we can use it as a kind of common ground. Yeah.
Oh, sorry, that's my fault.
Do we have any more questions? If not, I actually had a question, but oh, there is one from the audience.
Hello. This looks great. Where can I use it or find it or get it? How do I get it on my system?
Oh yes, this is just open source. So first of all here, and then it is the package with the nicks. So you can just first try, and then just feel free to have a contribution. Yeah, yeah. Thanks.
So I had a quick question as well, which is in a way the opposite of Ben's. So have you, like Ben asked, like what about generalizing that to other projects? I was kind of wondering which passes of ghc are particularly good to have a specialized custom view. Like I could imagine, say, the type checker. Like you kind of showed, like this seems really good if I'm trying to debug my build system or something, see what depends on what. What kind of visualizations have you thought of? Like if I have a type error and want to understand it, right? Like there's all kinds of things I can imagine.
Yeah. First of all, we should have a very good AST visualizer. So core, STG, also the Haskell HS. So yeah, that's the first thing. And then of course, the information in especially name can be interlinked together. That's very helpful for navigating what's going on inside the ghc. And then of course, ghc has lots of the internal things. So definitely we can have specialized view for that. Yeah.
Great. Let's thank the speaker one more time. And next.